in CCDC, the defense competition, you should sign up on this forum. They're trying to form a team. And there's a schedule here, so there's going to be a invitational in like 10 days and another one after that. So the invitationals, anybody can play. There are no restrictions. They don't really count very much, but there's a couple of invitationals, one on November 5th and one on December 3rd. So you can participate in them if you want to do this cyber defense competition. The official team that can win prizes has a bunch of rules, like you have to be a full-time student and stuff, but all that doesn't happen until next year. The official registration and regional qualifiers, so they're forming a team now. OpenSSL 1, the latest stable version is 3.0, supported. All right, Zui has posted some dates about the versions of OpenSSL, but I don't understand what they mean. Anyway, so fill out that form if you want to be on the Collegiate Cyber Defense Competition team, which is very good for you to do. And there's a talk tomorrow night with cybersecurity alumni, at least one of them from this college, talking about how they got a job and recommendations how you can get employed. These Bay ICT talks have been very good. I highly recommend it. And both of those things are worth extra credit. And for today, I'm not planning to cover another chapter, but just to demonstrate some projects. Probably not as many as I had planned. I had planned to do a bunch of them, but this whole bunch of projects, 600 to 605, appear to be irretrievably broken. They rely upon an Ethereum test network called Ropsten, and Ropsten seems to have been shut down as part of the move to Ethereum 2 that happened over the last month. So those projects don't work at all anymore, and they won't work until somebody ports them to another test network, which I saw done by somebody for a CTF, but they did not make the projects public. So I'm just going to start with 355 and 356, and then look at 303, and that's probably all the demos I'm going to do tonight. That's probably enough. So let's take a look at the stable version has only 1 year history. Yeah, well, that's right. The OpenSSL vulnerable version, but I thought a lot of people would jump on the latest version, but maybe not. Anyway, right, C355. Let me bring it up and let's see how it goes. There we are. That was a fallback function. All right. So I think I can just use this browser. Let's see if it works. I guess we'll see. I'll go to this one. Oh, I need to have a wallet. Well, actually, I probably don't need to have a wallet. The current RPC for this network has been deprecated. Yeah, that's kind of what happens when you use old networks. Anyway, let's see. And if oh, I remember this. City College blocks the right network here. I'm going to have to turn on my VPN. As I recall, it's okay to just turn it on while streaming, and it will cope. There might be a brief interruption in the streaming, but I have to get past the City College firewall. They block everything to do with cryptocurrency, even news about cryptocurrency. It's very rude. All right, now I seem to be connected again, and let me see if I can tell whether the looks like it's working. All right, let's see if I can reload this site. All right, looks like I can. All right, so let me put this on a different screen and leave this one here. All right. So let me just check and make sure people can still hear me. Please put a message in the chat if you can still see and hear me. I'm going to try and dig through my windows to make the chat visible. I guess I'm in trouble here. I need this screen to see what's going on the streaming. Okay, good, you can see me, thanks. All right, I'm going to have to try and put both of these things on one screen and cope. All right, so we're going to make the fallback contract, which is here. So let me do that. All right, so go to contracts, and there is no fallback, so I'll make one. New file, fallback, and put in this code. All right, and let me go to my instructions. All right, here's what we want to see. We want to see the fallback function there. There. So what's going on here is, I'll move this up here so people can see it. All right, so the fallback function is part of it, and you see it here, named fallback in this version of Solidity. And the point of this is if you call a contract in an inappropriate way, instead of just refusing to do anything, you can define a fallback function, and that's for all functions that cannot be resolved elsewhere. So there's a function called contribute and a function called withdraw, but if they call a function that doesn't exist or with the wrong parameters, it goes to fallback. So here's the three ways. You call a function that doesn't exist, call a function without passing in the required data, or if you just send ether to the contract's address without calling any function at all. In all those cases, it will run the fallback function. That's what it's there for. All right. Which means that if I can receive money from you, I then get an opportunity to execute code in the context of your contract, which is one of the very bizarre features of Solidity. So here, if you send it money, it will require that you send it some money greater than 0, and if you do that, then the owner will become the sender. So the variable owner will be set to you. That's an address up here. And so that's what the fallback function does in this case. All right. So we're going to compile this thing and deploy it in a JavaScript VM, which is good because then we do not need a working test blockchain network, which is a little bit hard to get right now. So we compile it, and it has 2 warnings but no errors. So we can deploy it, and we can deploy it on London is fine. These are the simulated blockchains that start with a bunch of contracts with 100 ether each, a bunch of users, and so we can just deploy it, and the green check mark, let me roll this up if I can find, there we are. The green check mark here means that that transaction succeeded, so I now have a deployed contract down here. All right, now we go back to my instructions. All right. So we've done all that. All right. Now, when you deploy the contract, it implements the constructor function, and that sets the owner equal to the person who paid the gas to deploy the contract. That's the point. That's the owner of something, and what this is a, all right. What's the name of this? It's just showing a fallback function. All right, so now we contribute ether to this function. We're going to send in 10 ether and expand this and contribute. Okay. All right, so let me do that. From the first account, I'll send 10 ether. All right. And I do it by contributing here. That transaction succeeds. The balance of the contract is now 10 ether. And my balance has fallen to about 90 ether, a little bit less because I had to pay some gas. All right. And now I can look at the balance if I want to see that in another unit. If I go down here, it puts the balance of the contract there, but I can also do get balance and then val down here, and that shows the same thing, 10 followed by 18 zeros because 10 to the minus 18, they're 10 to the 18 way in an ether. As if it matters, just the units they use, so that they're hoping that Ethereum will rise to some monstrous value like $100 million, and then you'll need those decimal places. All right, so now we can check the owner, and the owner down here is this address starting with 5B, and that is my address up here, 5B. Since I paid the ether to deploy it, and I just donated money, well, the main thing is just because I was the number when I deployed it, then the original constructor made me the owner. All right.
What do you contribute to?
What's that?
What do you contribute to?
I contributed to the contract. The contract has its own account number, and it can have a balance. So I put money in the contract. And so you can write, if any contract, you can deposit money to it, unless you write a function to refuse to accept money, which we did previously, and you can withdraw money if you put in a withdraw function. If you forgot to put in a withdraw function, the money you put in there is just lost. And that's how you destroy cryptocurrency. They burn cryptocurrency a lot. All you do is send it to an account where you've thrown away the private key and it's just gone, gone, gone. And there's a lot of techniques that do involve destroying money. Like when you want to move money from one blockchain to another, the cross-chain protocols typically just burn it on one chain and then prove they burned it and then mint it again on the other chain. That's how they do it. And that often does fail. All right, so if I go to the second account and I send 1 ether, and I go down to the lower level transaction and just send that money, that will hit the fallback function. So let's do that. So I go to the second account up here, which starts with AB. I send 1 Ether. And instead of using any of these, I go to the low-level interaction and do a transaction. I don't even think I need to fill in the account or anything. I think I can just hit yep, it works. And what I did is I'm going to hit the fallback function here. And so at the fallback function, the balance goes up to 11. The Ether went into there, but now I'm going to be the owner. If I hit this, I'm now AB. So because the fallback function reset the owner, I've now changed who owns all that Ether. And you can withdraw, but only if you're the owner. So I just effectively stole 10 Ether from the first guy because of this sloppily written function. All right. And so that's the point here. All right. And now you can withdraw it to take the money out. So that just shows you basically how a fallback function works. And some of the other attacks we've talked about use those fallback functions. So this is just a way to see what it does. That's not a common mistake somebody would make, but it does let you hopefully understand what the fallback function does.